What to do tonight?
Self-study assignment 1.
What's that?
Self-study assignment 1.
Yeah, assignment number 1. What time does it due?
11:59.
11:59. But you guys are all done, right? Because you did, a week ago, like you were supposed to, right? All right. So, any questions about that assignment or turning it in? All right. So Blackboard is kind of finicky, right? Blackboard doesn't always work like it's supposed to. It's a little bit buggy. Sometimes it crashes when you're uploading things. What should you not do?
Wait till all this is done.
You should not wait until 11:58 to turn in your stuff. Because what will happen if you wait till 11:58 to turn in your stuff? Blackboard's going to crash, right? And then you're going to turn in late. You're going to get docked 10 points for being late. Then you're going to send me an email saying, "Oh, it wasn't my fault. Blackboard crashed." And then I'm going to look and see that you tried to do it at 11:58, and I'm going to email you back and say, "That sucks, man. I'm sorry." You're sad. And then you're going to be upset with me, and you're going to bring my professor, and you're going to write like some mean, terrible thing about me, and then it's just going to be a terrible thing. How can we avoid that? Don't wait till the last minute. Yeah, upload it at like 11 o'clock. Or, 11:57. Upload it at 11:57, right? What I'm saying is, do not wait. I do not care if it's not your fault. If you turn in your thing late, you're going to get docked points for it, okay? So don't wait till the last minute. Like I said, if you had been doing what you're supposed to be doing, you would have turned this thing in like a week ago, right? So, any questions about that? All right. Any questions about anything that we've talked about so far? Not talked to, I guess. Cool. All right. So let's start with just like a little bit of a warm-up. Get the blood flowing, right? Let's say that f is a function of a, b, c, and d. And it's equal to a or b prime and c and d. My first question for you guys is, which of the two standard forms is this function in? Good, it's in sum of products. It's in SOP. What I'd like you to do right now is convert it to product of sums. It wasn't a rhetorical thing, once you do it. What's that mean?
Howdy.
We are working on taking this function that's in sum of products, converting it to product of sums. Okay, you know what? Everyone on the Discord, I'm going to move over to the correct Discord channel for this. All right, everybody got it? Say again? Use the distributive property. Yep, you're absolutely right. Which one? The first one or the second one? The second one, right? The second one states that XOR y and z is equal to x or y and x or z. All right, what do we do with that?
You said a equal to x.
Yeah. Let x equal a. Or y. B prime. I'll take that. What about Z?
CD.
C and D. Now, could you have done something like y is equal to B prime and C, and Z is equal to D? Yeah, that'd be just fine. You'll still get the right answer eventually. It'll just take you a different path. So that means we're going to get what? We're going to get f is equal to A or B prime and A or C and D. Now what? Do it again, right? And where do we do it again? Yeah, so we're going to do it again on A or C and D. Now in this case, let x equal what? A. Good. Y equals C and D equals Z. C equals D. So there we get our final answer now. F is equal to A or B prime and A or C and A or D. Cool. That's our final answer. That's product of sums. All right, any questions about that one?
Yeah. Why did it, that second part, how did that happen again?
How did
The
it happen
A
again?
plus C and the A plus D, yeah.
Somebody help out. What was the last step?
Just re-plug in the formula, just reuse the distributive formula, like the second one again.
Yeah, we just used the distributive property again. We just kept going.
Okay.
We used the exact same formula over again.
Okay.
Cool. Now, we were right to do that in 2 steps, but now I'm going to give us a little bit of a tool to speed things up. This second distributive property is extensible out to as many variables as you want. So, for example, I can say that x or w, y, and z is equal to x or w and x or y and x or z, right? And since our initial function was already in that form, we could have just done it all in one shot, right? Does that make sense? So we can modify, we can extend that second distributive out to as many additional functions as we want. All right, any questions about that? Cool. All right, now for something completely different. Let's talk now about complementing a function. Let's see. So what do we mean by complementing a function? Inverting, you're absolutely right. We mean taking f and figuring out what f prime is. Now to do that, the critical theorem that we need is going to be De Morgan's theorem. Right, which states that if we have x and y prime, that's equal to x prime or y prime, or if we have x or y, all of that prime, that's equal to x prime and y prime. So for the sake of expediency, I'm going to label this one as 1 and that one as 2. And let's work an example. So let's say that f is equal to quantity a prime or b and c prime. And I want to find f prime. First thing I do is just take everything that's in f and invert it. Thank you. So quantity A prime or B, C prime, prime. All right, which of our two De Morgan's theorems are we going to use first? Which one? The first one. Okay, so the first one is x and y prime is equal to x prime or y prime. And we're going to let x equal what?
A prime or B.
Good. A prime or B. And we'll let y equal what? C prime. Good. So that means we're going to get f prime is equal to what? Good. Yeah, A prime or B, all of that primed, or C. How come or C, not C prime? Right, because we already took the inverse, it was already C prime. We take the inverse of the inverse and get the thing back again. Remember this one, x prime prime is equal to x. So that's why C prime became C. Okay, now what? What's that?
Why did we get rid of the outside prime and all that stuff?
Because we applied De Morgan's theorem. This thing prime is this expression. Xy prime is equal to that. We already applied it, I guess, I would say. It happened. All right, what's next?
The second version, A prime or B.
Yeah, so we take this guy and flip it over. And which De Morgan's theorem will we use now? The second one, good. So that says that x or y prime is equal to x prime y prime. So we're going to let x equal what? Good, a prime. And y equal what? B. Which means that we're going to get f prime is equal to what? A and B prime, good. A and B prime, and still, or C. And once we have no more quantities, oh no. Guys, we might be in trouble. Once we have no more quantities, are we done? Or no more quantities that are being inverted? That's when we're finished. Another way to look at it is, what form is this function in? Which of the two standard forms? Yeah, this one is in product of sums, right? And this one is in which one? Sum of products, right? When you've gotten to the other standard form, that also lets you know that you're finished. Does that make sense? All right, I'm going to plug this in, but as we already illustrated, that socket doesn't work. So, unless they changed something in the last couple days, we might get out of class early.
Extra long week.
Extra long. Yeah. Okay, well, we're going to go until this thing dies, and then that'll be it. Okay, so that's complementing a function. Any questions about that? Okay, let's see. Next thing I want to talk about. Modify things. Actually, with what little time we probably have left, I'm going to skip over a thing. I'm going to quickly mention, we're not going to work an example, but we talked about a different and say an additional theorem for multiplying out. And that theorem is just this, that if we have x or y and not x or z, that's in product of sums, it's equal to x and z or x not and y. So you just got to pay attention. The inverse in something, the inverse in something else. All right. Any questions about that? If you go watch the lecture from this morning's class, I did an example that follows this up, but I want to make sure to get to the next thing for you guys before my tablet here dies. So just commit that one to memory and be prepared to use it. The thing I actually want to talk about today is the exclusive OR operation. We're going to add it to our bag of tricks. So before we had and, or, and not our fundamental operations, now we're going to add a new logic gate called exclusive OR, which a bunch of you I'm sure have already heard of. But basically what it means is if I have x exclusive ORed, or XORed, with y, that's going to be equal to 1 if and only if x equals 1 or y equals 1, but, and this is the important part, but not both. So one of them can be 1, but not both of them. So if we lay down a truth table for this, we'll have x and y, x XOR y, 0, 0, 0, 1, 1, 0, 1, 1. So if x or y are both 0, what is x XOR y? What? It's not 1. 0 XOR 0 is equal to, or the definition is equal to 1 if and only if x is equal to 1 or y is equal to 1, but not both. So if they're both 0, what do we got? Was it? And.
Would it be 1?
I was talking about this one, right? 0 XOR 0 is 0, right?
Yeah.
You're talking about the other one.
No, now I'm talking about the next one. No, I was talking about, I didn't realize I'd already written it out. Yeah. I was wondering why you guys were like, I was like, really, this one is obvious, right? Like, why are they struggling with that one? Yeah, it's 0. But if x is 0 and y is 0, now it's equal to 1. Good. If x is 1 and y is 0, XOR is equal to, and if x is 1 and y is 1, XOR is equal to 0. There we go. Cool. Scared me for a second. All right. How would we take the sentence? We're going to optimize it in a second, but how would we take the sentence XOR is equal to 1 if and only if x is 1 or y is 1, but not both, and express that as a Boolean expression, right? In terms of our ands, ors, and nots. So I said x or y is equal to something. What is that something? What you got?
Is it like an inverse and or something?
An inverse, it includes an inverse and, yeah.
Could it be at quantity x or y and not quantity x, y? It's like,
You're absolutely correct. Yeah, so it's, when you think about it, the sentence, it's x or y and not x and y, right? So, but this isn't in our standard form. We need to get it into a standard Boolean form. So what's the first thing we're going to do? Anytime you see some quantity of Boolean variables that's inverted, what are you going to do? What's that? Right, multiply it out.
did you do product of sums?
No, we just did it.
Distributive property.
Not distributive. Like we just did it.
Oh, the Morgan's theorem.
The Morgan's theorem, right? Anytime you see stuff being inverted, you're going to apply the Morgan's theorem. So we're not going to care about x or y just yet. But what happens to x and y not?
X prime or y prime.
Good. X prime or y prime. Now that's our product of subs form, which is nice. But if we want to get it into sum of products, we're going to distribute, so we're going to FOIL it out. And so that's going to give us what? X and x prime, or x and y prime, or x prime and y, or, oh, there it went. Class is missed. Now, hold on, I'm going to finish this example. Is there a marker here? Is there a marker anywhere? Dang, that's really sad. Oh wait, here's a marker. Rip. Alright. Hold on just a second, gang. There we go, we're gonna go there. Literally the last one.
Oh, we guess we.
Okay, what do we just have? We had
X and y.
x or y. We started with x or y and x and y prime. That's going to get us x or y and x prime or y prime. And then we FOIL them together. X and x prime, or x and y prime, or x prime and y, or, this is where we died, y and y prime. What is that going to simplify to?
And y prime or x prime and y.
Right? Good. Just these two guys. What happens to x and x naught? Right, that goes to 0. What about y and y naught?
Cancel out. Go to 0.
Also goes to 0. Right? So we're left with just x and y prime, or x prime and y, which makes sense if you think about it. Cool. All right. So the last thing is the schematic symbol, the logic diagram for XOR. Is our inputs. It's an OR gate, but it's got like this extra bit on the end. Let me draw the XOR symbol in the middle. And that's our X, XOR Y. There we go. And the shorthand term for this is XOR. And it's XOR. Anyone says XOR in my class, you'll be asked to leave. I don't care what your high school computer science teacher said. It's XOR, it's not XOR. All right. Cool. There we go. In that case, we kind of sped to the finish. The only thing we didn't do is in the morning section, I did a very long simplification example. That just took a little bit while. It took a long while to get through. If you're interested in that, go check out the stream for that section. Should be able to see that, yeah. I think. I'll make it available. Anyway, are there any other questions, comments, concerns before we get out way early? Yeah.
Those three are left for there.
Yeah. And I'm taking them off MediaSite and I'm putting them on YouTube, so everyone should be able to access them a lot easier because MediaSite sucks. You got a question?
I got a question. It's not school-related. Are those the William Painter hook glasses? The one with like the titanium alloy that can like unclip a beer, a cap bottle?
Yes.
All right. Is it true that it's like indestructible and has a lifetime warranty?
Yeah. Well, you want to like
Like
smash them right now?
I
See what happens?
saw the video and it like I recognized them the day one, but I couldn't remember. But then I saw the ad yesterday, and like I remembered.
Oh, dang.
Like I wanna buy them, but like I don't know. I didn't really believe the lifetime warranty.
I mean, we can find out. We can just smash them around the ground, see what happens.
Now, I see those videos, like I wanna buy one and try it.
I'll let you know what happens. I'll like run over with the car or something. All right. My sunglasses aside. And yes, you can open bottles. Let's see. What's due tonight? Unit 1, right? Yeah, don't wait till the last minute. If you haven't started on it yet, I recommend starting on it. It takes it's not short. Like it's designed to take you a week to finish. So if you haven't started it yet, you might want to get on that. So, any last questions, comments, concerns? Okay, well, I apologize. I'll make sure my tablet is charged in the section right before this one in the future, so this never happens again. And if there's nothing else, have a good long weekend. Be safe, don't do anything stupid, don't get sick. And I'll see you guys next Wednesday. All right, thank you. Cool. You too.
Have a great week.
You too, thank you. All right, guys, have a good weekend.